Let's move on and take a look at how language models like ChatGPT go from simply reading the internet to becoming helpful, trustworthy assistants. We'll start this video with what post-training is all about, dive into how it works, and wrap up with why it matters. Note that in the context of LLMs, post-training is commonly referred to as fine-tuning or instruction tuning. So first, the base model is trained using a process called pre-training, where it learns from massive amounts of internet text. The goal here isn't to create an assistant, it's to build a general-purpose model that can predict the next word or token based on context. Also, keep in mind that the base model has a knowledge cutoff date because of the static nature of the internet data included in pre-training. For example, GPT 4.5, released in winter 2025, has a cutoff date of June 2024. And since pre-training is expensive and resource intensive, it's not repeated too often. The pre-training stage is extremely expensive, taking months of compute time, thousands of GPUs, and billions of dollars. And at this point, the model isn't really an assistant. It's more like an internet document simulator. It can generate text that statistically looks like something you'd find online, but it doesn't yet know how to follow instructions or carry on a conversation. That's where post-training, aka fine-tuning, comes in, and it's just as important, even though it's cheaper and much faster. It depends on the model, but to give you a general idea, pre-training takes months to complete, while post-training usually takes just a few hours. The goal of post-training is to transform the base model into a helpful AI assistant, like ChatGPT, one that can answer questions, support multi-turn conversations, and behave in a way that feels human-like. There are two key parts to this process: supervised fine-tuning, or SFT, and reinforcement learning, or RL. Let's start with supervised fine-tuning. This is where we take the base model and continue training it. But now, instead of using internet text, we use structured conversations between humans and assistants. These conversations are created by so-called human labelers, who are contractors which are given detailed instructions by the company developing the model. They are asked to come up with thousands of prompts, and for each prompt, they write the ideal assistant response. Humans don't write everything from scratch. They use an existing LLM to generate questions and answers, and then they edit the answers. Take a look at this document that describes how to train language models to follow instructions with human feedback. The instructions people follow often emphasize three qualities: helpfulness, truthfulness, and harmlessness. The assistant learns by example, adopting the behavior and tone of the responses written by these labelers. Now, this dataset of conversations, called the SFT dataset, covers a wide range of topics and is formatted with clear distinctions between human inputs and assistant outputs. The conversations are tokenized into sequences that the model can learn from using the same algorithm as pre-training, predicting the next token in the sequence. But the key difference is that now it's learning from assistant-style conversations instead of raw web pages. As a result, the model starts picking up the statistical patterns of how an assistant should respond. It learns not just what to say, but how to say it, clear, concise, and aligned with the values defined during training. The outcome? A model that behaves like a helpful assistant, imitating the tone and quality of the human written examples. If you ask it something like, what are the top 10 mountain peaks in Europe? And that exact question and response were in its post-training data, it will likely generate the same answer. If not, it will fall back on what it learned during pre-training, blending both sources of knowledge. By the way, you can try different models on the Hugging Face playground. Just create a free account, generate a token under Settings, head to the playground, select the model you want to test, and run queries. Let's select Microsoft 5.4, which is a small, open source, state-of-the-art model developed by Microsoft. And I'm running the same query. Very well. Just play around with all these models. Now, there's a second part to post-training that's gaining more attention: reinforcement learning. Here, the model generates multiple possible responses to a prompt, and human evaluators or even automated systems rank or score those responses based on how well they align with the desired assistant behavior. The model then adjusts itself based on this feedback, learning to prefer better, more helpful responses. This approach is especially useful in complex domains like math or logic, where fine-tuning alone might not be enough. So to recap, post-training is what transforms a raw language model into a helpful assistant. With supervised fine-tuning, it learns from examples of good conversations. Then, through reinforcement learning, it refines its behavior even further. It's not perfect, of course, but the assistant we are chatting with today is the result of that powerful combination of learning steps. Now, it's worth noting that the first two stages, pre-training and supervised fine-tuning, have been around for years, and all major LLM providers use them. But reinforcement learning, or RL, is still a relatively new area. We'll take a quick break now, and in the next video, we'll dive deeper into RL.